How are you?
I'm fine. I took a quick peek at the order of these documents you sent me, and it's not easy to arrange them numerically in order.
Sorry about that.
That's okay. I looked at one that had 5 and maybe 6 on it, so I think this is the next one. I hope I didn't skip a couple of questions. If you realize that we did, let me know, and I'll go back and we'll pick it up next week.
Okay.
But as far as I can tell, this is the next question that we're looking at. So number 7.
So I was just guessing off the top of my head that quantity B would be bigger for number 7.
Well, let's not guess. No, seriously. Unless you have to. Guessing is a last alternative.
Okay.
The best thing to do in a problem like this, since we clearly can't add up all the odd integers, we don't have time to do that, well, let's take these 3 integers. Now, if those were the 3 integers, what would these 3 be on the right?
They would have to be 2, 4, 6.
Just 2 and 4. Notice that 2 is 1 greater than 1, and 198 is 1 less than 198.
Oh, right. Okay.
So
I see.
If I want 1, 3, 5, 7, this would be 2, 4, 6.
Got it.
Now,
I hadn't seen that.
The sum of that is 12. Sum of that is 16. And no matter how many digits you go, if that isn't convincing enough proof, then do 1, 3, 5, 7, 9, which would give you 2, 4, 6, and 8. You will still find that that is high.
Yeah, you're right.
If for no other reason than it's got one more digit in it.
Right. I hadn't seen that, excuse me, 198 was less.
Yeah. Okay. Let's look at 8. This is kind of a common problem whether you're looking at GRE, GMAT, SATs, or ACTs. What's in common between the numbers 2 and 32, besides the number 2?
Well, 2 is a factor of 32.
Okay, but it's more than a factor. In other words, we're looking at
they're both even
here. That is an exponential, and that is an exponential, meaning your variable's in the exponent. Okay?
Right,
so
okay.
We want to be looking for, can we turn 32 into 2 to some power? And yes, we can. 32 is 2 to the 5th.
Okay.
Be taken to the S, and that's equal to 2 to the T. You with me so far?
Right, yes.
Now, what does the left side become?
What is the what?
The left side become, using the rules of exponents.
Oh, gosh. 5.
No, start with the base. You multiply
2.
When you are doing, this is what I call double exponentiation. Because we have 2 being exponentiated, and then that whole quantity is being exponentiated. So whenever you have double exponentiation, you multiply.
Okay.
And just, let's go back for a moment. If I'm doing, I want to teach you all the rules about exponentiation. What's 2 to the 3rd times 2 to the 4th?
2 to the 12th? Oh, no, you add 2 to the 7th.
you add them. And notice that adding is one level less than multiplication. And that's the way to remember this.
What do you mean one level less?
Well, if you think about adding, it's a level less. When you learn math, you learn addition first, then you learn multiplication, then you learn exponentiation.
Okay, got it.
Okay? So to me, in my mind, addition is one level less than multiplication.
Right.
And if I am dividing, I'm going to subtract the exponents.
Right.
Because subtraction is one level less than division.
Right.
And the third rule is when I am double exponentiating. If I have 2 to the third, all to the fourth,
then you multiply.
Then I multiply, which is one level less than double exponentiation. You can think of it that way.
Okay.
I don't know if mathematically it's defined that way, but it certainly is to think of that way. The most important thing you want to make sure you don't ever do is the same thing to the exponents as is being done to the base. If you find yourself doing the same thing, then it can't be right.
Can you give me an example of doing the same thing? Because you kind of lost me there.
Yeah. If I multiply the exponents, I'm doing the same thing to the exponents as I am to the base. I was trying to multiply the bases.
But it should be 2 to the 7th.
Exactly. In other words, we're not going to do what we were doing to the bases. We're going to add the exponents. So you never do to the exponents what you're doing to the base.
Okay.
Okay? And that's a pretty good way to memorize it, because then you will never make the obvious mistake. The obvious mistake is to do the same thing. And if you don't do the same thing, you'll come up with what you need to do. And if you don't, then look at the numbers. Okay? It's easy enough to tell what the answer to that is. It's got to be 8 times 16. Well, 8 times 16 is 144. Is that the same as 2 to the 7th? Yes. Or, excuse me, 8 times 16 is 128, sorry. Doesn't help to make arithmetic mistakes. But 128 is 2 to the 7th. It's not 2 to the 12th. So you could always, let's say you forget the rule. Go back and try it on small numbers. Don't use 1. Use at least 2. Because 1 to any power is 1. So you don't find out anything by using 1.
Right.
But by using the number 2, you can figure out what the answer has to be. Same with 2 to the 4th divided by 2 to the 3rd. That's going to be 16 divided by 8, which is the answer 2. So clearly it's got to be 2 to the 1, which tells you that you are subtracting exponents.
Right.
All right. Now, let's see if we didn't do this problem. We didn't finish it. Sorry. Let me finish the problem. I got so involved in the rules of exponents. This is 2 to the 5th is how I'm going to write the number 32. So that is that. And if that's equal to 2 to the t, now by applying the rules of exponents, the left side is what?
2 to the 5th times s.
2 to the 5s.
To the 5s, right.
And if that's equal to 2 to the t, then we know 5s is equals
t.
And they're asking about that quantity. Well, how about if I divide both sides by t, and divide both sides by 5. I get s over t equals 1/5.
So wait a minute.
Let me go through that. Yeah, I did 2 steps.
Hold on.
I did 2 steps.
Can I ask my question?
Sure.
Okay, so I understand the 5s equals t.
Okay.
So under quantity 8, you have s over t.
So we have to manipulate that to produce an s over t.
Right.
So the first thing I'm going to do is divide by t. So now I have 5s over t equals 1.
Okay.
Now I want s over t. I don't want 5s over t. So I'm going to divide both sides by 5.
Okay, now I get it. So there you
get s over t equals 1/5. So they are equal.
So how do you recommend...
S over t is 1 over 5. I'm sorry, what?
How should I memorize all the exponential aspects of 2?
There's only 3 that you're going to have to deal with. And they're all the same base. In other words, the rules are this: b to the x times b to the y equals b to the what?
X plus y.
Okay, you got that one memorized already. B to the x divided by b to the y equals?
Subtracting those two.
What's the answer?
X and y. Okay, but my question wasn't in regards to the exponential rules. My question was, if I looked at 32, I'm not at the point in my math skills that I would know that that was 2 to the 5th.
All right. That's actually one of the really good things to know in math, especially for an exam like this. And that is powers of 2. It's not a bad thing.
Should I know powers of 2 and powers of 3?
Well, powers of 2 are going to be more important.
Okay.
Let's go through. What's the next one?
4.
Okay, keep going.
8.
Keep going.
16.
Keep going.
And then is it 32?
Keep going.
So I'm just doubling them, 64.
Exactly. That's all you're doing.
And 128.
1, that's 2 to the 2, that's 2 to the 3, and then 128. Okay. This is the way computers developed. I doubt that you're go back far enough to remember, but when computers originally came out, they had you had 8 kilobytes and then 16 kilobytes and 32 kilobytes, and finally they got up to megabytes, but it went in these powers of 2. So these have all kinds of applications in the real world, but that's one of the few. But yeah, it's worth knowing them at least up to 64. I mean, I don't know that you necessarily have to know. In other words, knowing 2 to the 5th, I would say you want to know up to that. Now, powers of 3, not as important. You don't have to memorize them up as deep, but they go 3, 9, 27, 81.
Okay.
That's 3 to the 1, 3 squared, 3 cubed, 3 to the 4th.
Okay.
And that's probably all you need to know for 3s. 4s go 4, 16, 64, 256. Probably all you need to know for 4s. 5, 25, 125. And that's really it. I wouldn't worry about anything beyond 5s.
Okay.
But the 2s are the most important.
Okay, good to know.
Yeah, and that way when you see numbers 2 and 32 and they're involved in exponential equations, look for the common exponential base. Not the common factor, but the common exponential base. They're different.
Okay.
In other words, 2 is a factor of 32. 2 times 16 is 32. But that's not what we're really looking for. It's,
sure.
can I express 32 as a power of 2?
Okay. Thank you.
Now, I think the next page, I was looking at them, I believe is 93. No, it isn't. It isn't that important that we go through them in numerical order.
Right.
But it's going to be hard to figure out what we've done and what we haven't done if we don't go.
Okay.
Look at 91, because no, 92 is closer. We'll go to 92 and just know that we must have skipped 9 and 10 because we just did 7 and 8. And I'm not 100% sure that it's the same section. Did you send me all of them from the same section?
I did.
Okay, good. Then this is all section 1. And we're going to have 2 more sessions.
Section
correct?
5 of test 2.
Do we have 2 more sessions or 1? Are we just having a session next Friday? You take your test next Saturday?
No, I take it on Monday the 20th. So we could do the 19th.
So yes,
well.
So we're due to have 2 more sessions. I may or may not need the rest of this test.
Okay.
We'll see how far we get.
Sure.
So this is fairly straightforward. This is a concept that's extremely important in all tests also. Just like exponentials, having 2 parallel lines and a transversal. Okay?
Okay.
Let's go over that. 2 parallel lines and, oops, hold on a second. When you have 2 parallel lines and a transversal, parallel usually is signified by that. You'll notice you create 8 angles. The key is understanding that you only create 2 angles and they are always supplementary to one another. In other words, you create angle 1, an obtuse angle, and angle 2, an acute angle. And angle 1 plus angle 2 equals 180.
Right.
And the other 8 angles, or the other 6 angles, are either the same measurement as 1 or 2. I think we went through this before and you had it just perfect. In other words,
I tend to do really...
Go ahead.
I was going to say I tend to do really well on the geometry.
Okay, tell me what other angles are equal to 1.
So based on what your diagram is, if everything is drawn accordingly, equal to 1 would be 5.
Okay, that's 1. What else? There's 2 others.
8.
Okay.
And 4.
Okay. And the easy way to tell it is that's obtuse, that's acute. So all you got to do is check every other obtuse angle is going to be 1. Every other acute angle is going to be 2.
Mm-hmm.
So every time you have a parallel lines with a transversal, this is true.
Right.
Well, what they're asking here, and it works in reverse. Let me mention that. Let's say I don't know they're parallel. But you tell me that angle 3 is the same as angle 6. Guess what? That makes them parallel.
Okay. Good to know.
So it's a two-way theorem. So they're asking, what does y have to be to make that parallel to that? Oh, excuse me. No, that's not what it's asking. It's telling you that they're parallel.
Mm-hmm.
What is y?
So would it be 35 divided by 2?
Yeah. In other words, we know that 2y equals 35. They're both severely acute. So they're the ones that are going to be equal to one another. So y is 17.5.
Okay.
Okay. Let me scroll. Hold on. Another statistics problem. Good thing I spent all summer reading the statistics book, which I'm now reading for the second time through. I've never tutored statistics before, but I'm starting to get enough requests that I decided I would dedicate my summer to learning statistics well enough to tutor it. And I'm about half.
Well, good.
Well, like I said, I'm 2/3 of the way through the second reading of the book, and I have a statistics student. So you'd think I would get there, but it's a hard subject to tutor, let me tell you.
I bet.
Okay, standard deviation of 5. Trying to think of how to explain this. If you had to guess, what would you guess? I know I said don't guess, but sometimes if you don't know how to do it, guessing is your best bet.
I am guessing that 8 is not the answer.
Well, I think it is the answer.
You think it is? Okay.
I think it is, yeah. Here, let me go through my reasoning. First of all, when you talk about standard deviation, you're really normally talking about a normally distributed curve.
Mm-hmm.
Where this is the mean. And standard deviation is a measure of spread. In other words, if I go one standard deviation to the right, that's x bar plus sigma. If I draw a dotted line, and I go one standard deviation to the left, that's x bar minus sigma, sigma being the standard deviation. Turns out that in any normal distribution, this represents 68% of the area under that curve.
Okay.
If I were to go 2 standard deviations on either side, I would have 95% of the area under the curve. In other words, if I draw 2 standard deviations away from the mean, and if I go 3 standard deviations, I end up with 99.4% of the area under the curve.
Okay.
So if I told you that something had a bigger standard deviation, then it's going to be more like that, right?
Correct.
Gotta be, because if I want 68% of the area under the curve, I'm going to have to widen my standard deviation. So that standard deviation is going to be bigger than the curve on my left.
Right.
And that's basically what standard deviation means, is it's a measure of spread of the data. If I give you a bunch of data, and if I give you 9 numbers, and I give you 3 ones, 3 twos, and 3 threes, that doesn't have a big spread to it. But if I give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's got a much bigger spread. The standard deviation on the second set of numbers definitely greater than the standard deviation on the first set of numbers.
Okay.
Okay. So when we say we have a standard deviation of 5, it basically defines a curve of that shape. Now, if I take every value in here and add 3 to it, all it does is it shifts the mean over by 3. It doesn't change the shape of the curve.
Oh, so it just moves over. Okay.
Yeah. In other words, understanding that standard deviation, if they both have a standard deviation of 5, then the curves would look exactly the same. And obviously, if I add 3 to every number, I'm increasing the mean by 3.
Correct.
And I'm not changing the spread. Let's say the pink was 1, 4, 7, 10, 13, and so forth. And I add 3 numbers to each of those for the black, or if I add 3 to each of them, I've got the same spread. Well, there's whatever my mean is. My mean might be 7 in the first case, but it's got the same spread as my mean of 10.
Right.
And I think that's the best explanation for this. So my standard deviation is 5. It didn't change. You don't change the spread of the data by adding a constant to each number.
So you're saying that it isn't 8.
It isn't 8. I
was right.
I first thought it was 8, and then I realized when I started working through the logic of it that the standard deviation doesn't change if you don't change the shape of the curve. And you don't change the shape of the curve by adding 3 to every number in it. You just move it to the right by 3 units.
So with that same curve, what would they need to do to change the spread?
Well, if you added 1 to the lower half of the numbers and you added 3 to the higher half of the numbers, you're spreading them apart.
Points. So you're saying give more data points.
Yeah. I don't know how much more we want to spend on this. Let me just give you the last part that I can think of. If I have a bunch of data points that are lined up like this, not in a normal distribution, and I want to know what the standard deviation is, well, first of all, I fit a regression line through there, and the line that goes through there is the line. The standard deviation is the square root of each of these lengths of these vertical lines squared. So this distance here, square it. Add it to this distance here, square it. Add it to this distance here, square it. Take the square root of the whole thing. That's the definition of standard deviation.
Oh, okay.
If I have a bunch of data points that are much closer aligned, and I draw a straight line through that, you can see that the sum of all of those differences is going to be much smaller.
Right.
This has a far less standard deviation than that does.
So the curve on the left would be tighter?
Yes.
Okay, I
Let's
understand now.
assume that the curve on the right has a standard deviation of 5.
Right.
Well, if I add 3 to each value, my first value is there, my next value is there, my next value is here, you'll notice the spread doesn't change.
No.
In other words, when I get my black line and I draw the best line that goes through that, my standard deviation is the same. It's still,
Right.
those values are still the same. It's still just as far from my perfect line that I can draw through those data points. So this perhaps is a better illustration than the normal curve. I don't know. Either one, the key thing to remember is that standard deviation is a measure of spread.
Okay, I can remember that.
Now, the mean, if they'd have said, what happens to the mean? It's going to go up by 3.
Right.
Because you're adding 3 to every number. And you get the mean by adding all the numbers and dividing by how many numbers there are. So if you just add 3 to every number, the mean goes up by 3. And that is the difference between my black sloped line and my red sloped line. Because my black is exactly 3 higher. That number right there is 3. That is 3. That is 3. And so forth. So as all I've done is moved my straight line to the left and up, but I haven't changed the spread at all.
Got it.
Okay. Now we're looking for 13. All right. Let's see what 93 gives us. 13. Okay. We're going in the right direction.
Uh-oh, I cut it off.
Yeah, that's all right. I can still read it, I think. Yeah. If your life depended on it, how would you do this problem? I always like to say that because that's the way I would like you to approach all these problems, like your life depends on it. Even though I know it doesn't, I think it helps to really maintain focus and forces you to do it in a way that you couldn't possibly make a mistake. What way would that be?
Well, one way would be to plug in the answers
called back
for y.
I love that way. That's back solving.
And since there's the negative numbers, like maybe start with E and then start with A.
Not sure that there's a reason why you would go that route.
Well, just to see what your answer,
I would start with that. Why? Because the math is the easiest.
Okay.
Okay. So
8 minus 3 is 5 divided by 4.
I didn't say A, I said B.
Oh, you said B?
That's all right. I don't have any problem with starting with A. It's just the math's a little harder just because 4 is a bigger number than 1. But in this case here, it's so easy that it's not going to matter which one we start with in terms of the arithmetic. So yeah, let's start with A. Okay, so you had 8 minus 3, which is 5 over 4. Is that equal to 3 minus 4 over 2?
No.
All right, immediately. Now we'll try B. Here we have 2 minus 3 over 1. Is that equal to 3 minus 1 over 2?
So the one on the left is negative 1 and the one on the right is 1.
Now let's try negative 1. We got negative 2 minus 3 over negative 1. is that equal to 3 minus a negative 1, don't drop negative signs, over that?
So I'm going to start on the right side on this one. That would be 4 over 2, which would be 2.
Okay.
And on the other side, negative 2 minus 3 would be plus negative 3, which is negative 5 over negative 1. So no.
We're only down to 2 left. So we got 2 times minus 3 all over minus 3. Is that equal to 3 minus a minus 3 all over 2?
So 2 times negative 3 is negative 6. Minus 3 is negative 3.
Hold on.
Wait, no,
Negative
wait.
6 minus
Negative
3.
6, that's negative 9.
Okay, let me ask you something here. Most calculators are different. And it's actually sometimes difficult to do this depending on the calculator you're using. So here's what I'm going to suggest to you. Before you take the test, for sure find out what kind of calculator you're using, because it can make a big difference when you go to do problems like that.
Okay, hold on. I think I already have.
That has a negative key, and I also have the same calculator has a subtraction key.
So I have the answer to that question in my GRE book.
Okay.
Let me find it.
My only thing that I want to make sure is that you know how to do it on your calculator. I don't want you making mistakes like one could make arithmetically there.
So the calculator, they have a picture of it here. I could just take a picture of it and send it to you if you want.
That's a good start. Why don't you do that?
Okay.
And I can at least look at it and see what kind of capabilities you're going to have using it.
I am sending it to you.
Anyway, if you finish the math on this problem, the left side turns into positive 3, and the right side turns into positive 3.
Excuse me. Hold on just a minute. Ah. It's not letting me put the picture in for some reason.
What's it say at the top of the calculator? Is it a TI-84 or a TI-Nspire?
It doesn't say anything like that.
Okay, I'm going to need to see a picture of its face. Not today, but before next week.
Oh, I've got it. I'll just copy and paste.
Okay. Do you have access to that calculator right now?
Not that particular one.
Okay, because I want to test whichever calculator you're going to use. I want to make sure you know exactly how to use it when you're going to add and subtract positive and negative numbers.
Okay, here it is.
Okay. I'm going to wait to look at it until we finish this problem, because the moment I look at it, I erase everything I've written.
Yeah, that's fine. I just sent it to you.
Okay. Do you see where the bottom turns into positive 3?
Where are you looking right now?
Right here.
The bottom turns into positive 3? I do not.
Bottom left. We have
the numerator.
Well,
the denominator
turns into negative 9. In other words, we have a negative 6 minus 3, which is negative 9, divided by a negative 3, that equals positive 3.
Oh, okay.
The right side turns into positive 6 divided by 2. That's equal to positive 3. So we found our answer.
We did.
Yeah, it's D. In other words, I found it by substituting minus 3 in for y, and that remains an equation. That's the hard way to do it. Let me show you. Well, it could be the hard way to do it. The reason I said if your life depends on it is because this other way is going to be quicker, but if my life depended on it, I would do what I just did.
Okay.
In other words, I know that if we answer D, it works.
Right.
Well, if I try to solve this algebraically, my first step is to cross multiply. With me?
Yes.
Now distribute. Now we're looking at a quadratic. In a quadratic, I want everything on one side, and I want the coefficient of the y squared term to be positive, so I'm going to move everything that's on the right to the left.
Okay.
And there's our quadratic. And now we know that to solve this, I got to factor it. And I get y minus 3 times y plus 2, which tells me that my solution is y equal 3 or y equal minus 2. Either of those would work. They didn't give us minus 2 as one of the options.
Nor did they give us 3.
Yeah, you're right. What did I do wrong here?
Maybe it's plus 3 and minus 2.
Hold on. It's plus y. Right here. When I move the 3y over to the left, it turns into plus 1y. And once you do that, it is plus 3 and minus 2, which means my two solutions are minus 3 and plus 2. Another reason why I wouldn't have used this technique if my life depended on it, because I'd be dead.
Right.
Okay? Because I had to factor that thing properly. And not only that, I had to do the algebra. Where I made my mistake was actually this step right here.
Right.
When I moved everything to one side, I made a mistake. So, which way you use, I'm not sure what's harder. We had to plug in 4 a bunch of times to figure out that it didn't work. 1, it didn't work. -1 didn't work. We finally found D that worked. And once you find that it works, you're 100% sure of it.
Right.
There's no way that minus 3 does not work. So if I had to go with my life, I would do it that way.
Right.
But this is another way to do it, where you cross multiply. In other words, you're algebraically solving it this way.
Okay.
You're not back solving it. Back solving it is where you take the answers, plug them in, see which one works. But algebraically solving it, I didn't do any of that. I just came up with that answer. And I know that either of these answers works in that equation. And since the only one they gave us was minus 3, that's our answer.
Right.
All right, let's see. I haven't looked at these at all in detail. I was just trying to find the order of the problems. List K consists of those 5 numbers. Which of the following lists of numbers have the same range?
So 10 minus 10 is 0, right?
It's not 10 minus 10. It's 10 minus.
Oh, that would be 10, that would be 20.
Exactly. And really the way
So
to do
B.
that, the way to think about this is to always picture in your head a number line.
Uh-huh.
Minus 10 is way over here. Plus 10 is way over here. So the
Right.
difference between minus 10 and plus 10 can't be 0.
You're right.
It's a long
So
way. It's that distance there.
I would say D for sure.
Wow. This is one of those, I guess the square means there can be more than one answer, huh?
What do you mean?
I
Oh,
think so.
yeah.
Yeah,
I
select
guess,
all
yeah.
the answer choices that apply. Yeah, D is definitely has a range. 22 minus 2 is 20.
E.
Okay.
And I'm thinking B.
Yep. All three of them have a range from highest to lowest of 20. Whereas C is 10 and A is 30.
Right.
All right. Let's see if we can find 15.
Just keeping you on your toes.
I don't think this one's it.
But we haven't done it.
These
So.
are 9 and 10.
Yep.
Oh, yeah, because we did 7 and 8 starting off today. So we do this page. Now we'll be in numerical order.
I think I gave you 10 on a separate picture.
Okay. Well, let's see if we can do 9.
Oh, we did. Didn't we do 9?
Don't believe we did. I don't recognize it. No, we ended up with 5 or 6 last session, and that's why I started with 7,
Oh, okay.
8 today.
Because this kind of looks similar to one of the ones we did last time.
Well, that's not rare. In other words, this is our second test. So I don't know if it'd be similar to one we did last session, but it would definitely be similar. They would probably have a question regarding this in every test.
Right.
In other words, this has to do with the arithmetic mean.
I think the other one was the random.
Yeah,
if he picked it, which was the one that was defective.
We have not done this one because I haven't.
Correct.
I'm not sure I know how to do it. Let me look at it.
I'm assuming it says 50 as in 50 boxes.
Yes. So we have 50 boxes each with 30 parts in them. And somebody recorded the number of defective parts in each of the 50 boxes. And the average of the 50 recorded number of defective parts was 1.12 per box. 1.12 out of 30. Only one, they never make it easy. Only one error was recorded in recording the 50 numbers. Okay. One defective part in a certain box was incorrectly recorded as a 10. So, if we look at that, we theoretically could have 1.12 in the first box, 1.12 in the second box. In other words, if all 50 boxes had 1.12 defective parts, you would have a mean of 1.12, right?
Correct.
However, that total would add up to 50, 5 times 12 is 60. So it would be 56.0 if I multiply that by 50.
Okay.
So that would be the total if nobody made a mistake. But what they're saying is that one of the boxes, which had one defective part, was incorrectly recorded as 10. Therefore, my total is 9 more than this. So here's the situation. If we added up all 50 boxes, we would have come up with 65 defective parts with this mistake. Whereas the true number is 56. Because on one of the boxes, they made a mistake by 9.
Right.
Okay, so that's what we know so far. Now what we're looking for, the actual average number of defective parts per box. Okay, so
wait, one of the boxes
47. It's not.
I have a question about the problem.
Okay.
When it says only one error was made in recording the 50 numbers, one defective part was incorrectly recorded as 10, that messes up the average in that particular box, right? Yes. Because the average is 1.12.
The average of all of them.
Oh, okay.
In other words, they came up with an average of 1.12, which is 56 defective parts. Right? And we know that they have 9 more defective parts than they actually had. In other words, 56 is not the number of defective parts. There were 47 defective parts.
Wait, how do you get 47?
Because by making a mistake and recording it as 10 instead of 1, the total defective parts was overcounted by 9.
Yeah, but
I did the analysis wrong by...
Oh, okay. I understand now.
Okay.
I understand now.
Okay. So, in other words, instead of 56 defective parts, there were really only 47.
Okay.
Okay. Now tell me what the average number of defective parts per box is. If there were only 47 defective parts in all 50 boxes.
So that would be 47 divided by 50?
Use your calculator. Yes, 47 divided by 50.
Hold on, getting my calculator. Exactly 0.94.
They are equal.
Yep.
Well, that was a clever problem. I've never quite seen one like that before. All right, let's see if we can find 10. Well, could it be the very next page? No. And for some reason, I don't have 96 on here. I might actually not have the one that has 10. Let me just go through these real quick. We did that one. So we did 5 and we did 6. And there's 15. That's what we're looking for next. So 99 is where we want to go next, unless we can find problem 10. And if we can't, it means we did this one. So 10 must be on image 96. We'll pick that one up next time. I have it. But let's continue on, as long as we This is in. Only one we're missing now is 10.
Okay. So are you saying I didn't send it to you?
No, I think you did. It's just that when I downloaded each one of them, some reason my 96 didn't download. I can go find it. And I got the email that you attached them all.
Okay.
I'm sure I can find it. But let's just keep going rather than spending that time me looking for it.
Okay.
So her 2004 income was 20% greater than her income in 2003. What's the ratio of her income in 2004 to 2003? It's a really easy way to figure this out. Because they're asking about ratios. They're not asking about what her income was. They're just asking about ratios. So when I said, what's a good way to figure this out? Plug in numbers. Her 2003 income, 100 bucks.
Oh, I see what you're saying. Okay.
What's her 2004 income?
Times 0.2, right?
Actually, times 1.2.
Oh, 1.2?
That's the easiest way to do it. You could multiply it by 0.2 and add it to 100, but that's the same as multiplying 100 by 1.2.
Okay.
Okay. Now we can see exactly what the answer has to be. What is the ratio of her income in 2004 to her income in 2003? That is 6/5.
Because simplifying it by 20. Got it.
And then just cut it in half, top and bottom.
Right.
Okay.
Okay. And we have one more minute.
Numbers I wanted. I could have made her income 1,000. Wouldn't have mattered because they're talking about ratios. I could have made her income $1.
Right.
So, okay.
So we can pick it up here next time?
Yeah, can do that.
Okay.
The next problem is going to be similar. I'm looking at a variable in the paragraph and I'm looking at variables in the answers. That means I should be able to plug in any number I want for n and solve this problem.
Okay. Let's take it from there next time.
Whenever you see that, think about that solution. When you see variables in the problem and the same variables in every single answer, then it means n is not a specific number. N can be anything. So plug in something easy like 5 for n, and then that fraction will become a lot simpler. So we'll start with 16 next time, or 10 if I find it.
Okay, great.
All right.
Thank you.
You're welcome.
Bye.